Hello everyone, welcome back to my channel. And today we're diving into one of the most important topic in data science and machine learning, which is called data preprocessing fundamentals. It is so essential techniques for preparing a raw data for analysis and mining, and these methods transform, reduce, and optimize dataset to improve algorithms performance and extract meaningful insight. So before any models can perform well, we need clean, well-structured data. So in this video, I will guide you through the key pre-processing techniques with a real-world example and that transform raw data into a meaningful insight. So let's get started. So data pre-processing include several important techniques such as regressions, which mean combine attribute or objects to reduce data size and create a more stable representations. We have a sampling which means selecting representative subset when processing the entire dataset is too expensive or time consuming. Dimensionality reductions, reducing feature space while preserving essentials, informations and avoiding cost of dimensionality. And the last one is features engineering. So creating, selecting, and transforming attribute to capture important patterns for more effectively. So these techniques are widely used in industry like Netflix recommendations, Google Maps, navigations, also healthcare predictions, and the fraud detections in banking. So let's talk one by one. So aggregations benefit. So aggregation is all about combining data. So it helps with data reductions, making big data sets more manageable. Um, Also, it provide a stability. Aggregate data has less noise and variabilities, and also it's enable analysis at multiple levels like city groups into religions and regions into countries. For the real examples like e-commerce website like Amazon's aggregate like million of data of like daily transactions into a weekly or monthly set report. So this help them to see the patterns like a seasonal like demands of the best selling categories. So aggregations make a big data simpler and more stable or easy to analyze. So let's talk about the sampling instead of processing an entire data set, which can be very expensive. So we take smaller like representative sample. So there are different strategies such as simple random sampling, which means that every items have a equal chance without replacement. So sampling without replacement like selecting item removed from populations preventing duplicating. Sampling with replacement, so item remain in populations or allowing multiple selection at the same object. And certified sampling, which means split data into partitions and draw a random sample for each partitions. So the key principle is like effective samplings require representative samples that maintain the original data's properties. So with the real world example, think of it like a Google Map. So Google Map don't need like a traffic data from every car on the road. Instead, they just like sample GPS data from fractions of drivers, yet like, still provide accurate traffic predictions. So let's move to the curse of dimensionality. So as the number of the feature growth, data become sparse and harder to analyze. Like it's the problem is like its distance between points become less meaningful. So algorithm like clustering or outlier like detect loss of effectiveness. So this is called the curse of dimensionality. For example, in the real world, so the face recognitions, each pixel have like image in the features with 1,000 pixels, but the data sets become huge and like computationally, so it's expensive. That's why we need dimensionality reductions. What is dimensionality reduction method? So dimensionality reductions like compresses data while preserving essential informations. So a common method such as like a principal components analysis, which is called PCA, like find a difference of maximum variance, and also like isomap, so construct a neighborhood graph or like and compute a shortest path distance for nonlinear dimensionality reductions. And also we have singular value discompositions, so like metric factorizations techniques for reducing dimensionality while preserving essential data structures. So in the real world example, let's talk about Netflix. So Netflix use dimensionality reductions on the user rating. So instead of keeping 1,000 of ratings per user, it reduced them to the factors like action movie fans or romantic comedy lovers, and this powered their recommendation systems. So fewer dimensions, but still meaningful insight. And another technique is called feature selection techniques. So feature selection is about choosing the right attribute and removing like a relevant or redundant ones. So the techniques include a brute force approach, which is called a testing all the subset, and in-depth approach, apply like statistical tests and before like modeling, and wrapper method is like testing subset with a model, and in-depth. And also the last one is a wrapper approach, like use data mining algorithms as a black box to find your optimal feature subsets. So the goal is to remove redundant features, duplicate information, also irrelevant features, no useful information for the task. With the real world examples in healthcare, like predicting a heart disease may start with 50 plus features, but features like might show the only age or like cholesterols, blood pressures, or smoking habits are the most relevant. So this improves accuracies and reduce complexity. And another one is distance metric. Distance measures like how far apart the data points are, and we also have Manhattan's distance one norms like moving along city blocks, Euclidean distance, like a straight line distance, and supremum distance, which mean the maximum difference between attribute. uh, for the example, like the e-commerce, like when you see the customer who bought this also bought that, the system use distance metric like Euclideans or like a causing distance the distance to find user with a similar shopping behavior. And also we have a similarities measure. Similarity measures like compare how alike objects are, and we have a binary data similarity, which means matching a coefficient and a Jacob coefficients, and continuous data, which means causing similarities correlations. For example, like Spotify use causing similarity to recommend song. If two tracks have a similar audio features, Spotify groups them in together in your playlist. So this is how you discover a new music that match your tastes. And the last one is like density based analysis. Density based analysis like look how tightly point are grouped, and we have a call based. So call based density, which means dividing space into the grid and counting point, and center based is counting point within a radius, and the graph based using network connectivities. For example, bank use density-based clustering fraud detections. If the transaction is far outside your normal spending cluster, it may trigger a flood alert. So density-based methods are essential for clustering and anomaly and anomaly detections. And that's it for my that's it. I mean, like, we cover the fundamentals of data preprocessing with the real example, aggregations with Amazon sales, like sampling with Google Maps, and dimensionality reductions with Netflix, also like feature selections with healthcare, and distance, similarity in Spotify's and e-commerce, and density analysis and for detections. Remember, pre-processing is the fundamentals of every data science project. Without it, even the best AI model won't work properly. So if you found this helpful, don't forget to like, subscribe, and share this video to your friends, and see you in the next video. Goodbye.